Chapter 1, Section 2, the commutative, associative, and distributive laws. The first one we're going to go through is commutative and the associative and distributive. And we're going to talk about how the distributive property works with factoring. Factor is a part of a multiplication, and we'll talk about that when we get to that. These words are going to be important to know. We're going to have, I hate to say that the reason you need to study something is for a test, but the language of algebra is pretty set. It's pretty static. It's pretty consistent between any math books you get into. So if you learn the correct terminology, it's going to help you a lot as you go on with math and the process of problem solving. And as you're going through the book, it's going to use these words, and hopefully that will have some meaning to you. Well, they talk about these things here too with just straight math. So like if we had these expressions with just numbers in there like 4 plus 4 plus 4, which is the same as 3 times 4, and 4 times 3 represent the same number, and those kinds of things. They're talking about expressions that are equivalent, or in other words, they have the same value or the same evaluation if you put the same number in for the variable. When we get into equations, we'll talk about equivalency too when we're using some other principles to solve equations. So they're tying into what we've gone through with expressions and looking at this, and they're saying, hey, we notice that when we change the order of addition, it doesn't change the value that we come out with, and that's the commutative law. And it works for addition and multiplication. And these boxes here, and they're starting to show or explain things with algebra, with expressions, equal signs, and expressions using variables. And when they have these like a plus b, that means for any numbers a and b, it'll equal a plus b will equal b plus a. So it kind of covers all our bases for numbers, and they're telling us this is a law. In other words, it works for all numbers with this property of addition. And so this statement right here, this equation really explains the commutative law. So we're going to really, as you get the language of algebra down, you can see, get a lot of information from just these equation in this case. Well, for multiplication, a and b, if you have a letter variable against another variable or a number times or next to a variable, there is multiplication going on. So they're saying if I have a times b, it's equal to b times a. What changed was the order of the multiplication. Okay, that's the commutative law. So when they ask you questions here like show the commutative law for this expression, well, I have addition. Yeah, I can use the commutative property on addition. So I could rewrite this in a different order. I'd rewrite it as 5 plus y. Now 9x is 9 times x, so I could rewrite that as x times 9 using the commutative property of multiplication. Now this next expression has addition in it. It also has multiplication. So if they said use the commutative law of addition, I would only change the order of the addition. So I would switch the order of the addition here. The 7 would move with this AB. This AB is a multiplication going on. So when they say the commutative law of addition, they're saying I just want to see that commutative law used on the property of addition. If they have this one, they say I want the commutative property of multiplication, then I would leave the addition in the same order and only change the order of the multiplication. This a times b changes to b times a. And if they wanted to use both, I'd change the order of the addition. I'd have the multiplication come out in first, and the 7 is the second add-in or part of the addition. And then I'd also change the order of the multiplication and change that to BA. So really, when we get into the homework and those kinds of things or quizzes, make sure you read what they want you to do and only do it specifically on the operation that they're talking about. Now, the associative law is a grouping thing, and it works on addition and multiplication. And again, they go into, let's look at these simple additions. And if I took this 3 plus the quantity 8 plus 4, I get 3 plus 12 is 15. Well, if I change the grouping deal, according to order of operations, what PEMDAS is the pneumatic for it, we do parentheses or grouping first, exponents next, and then multiplication and division left or right. It doesn't mean that multiplication comes ahead of division. It's just when you see those two operations in an expression, we just go left to right on it. And the same thing with addition and subtraction, the last part of that. It doesn't mean that addition comes before any subtractions. It's just whatever comes first, coming from left to right. Well, according to order of operations, when they give us this original thing, I'd have to do this addition in the parentheses and get this 12. And then I can do the next addition, which would be 3 plus 12 is 15. Well, if I change the grouping, it changes the order of operations, doesn't it? So now instead of getting this 12, I get this 3 plus 8, which is 11, right here. And then I still have to add the 4, and I still get 15. And then they show this same idea of changing the grouping symbols for multiplication, and you end up with the same result. And that is a pretty good illustration of what the associative law does. So the associative law, here they show it with any numbers A, B, and C. These are variables, which means I could write these variables for represent any numbers. If I have this addition of A plus the quantity B plus C, the associative law allows me to change the grouping. Notice that in this grouping B plus C is occurring. And it could change order, but that's a different property, right? The commutative. Well, in this side of the equal sign, there's different variables in here. The B is in the grouping again, but then it has to be added to A. That is the associative property. If I have all addition and I just change the grouping of that addition, I'll end up with the same result. And with multiplication, if I have A times the quantity B plus C. Now in order of operations here, I'd have to do this multiplication first and then multiply A times it. Well, they say it would be exactly the same as taking the grouping of A and B and multiplying then times C. And that's the associative property. And here's some examples of that. If I have A plus the quantity Z plus 3 and they want me to use the associative law to rewrite this expression a different way, I would change what's in the grouping symbols. And here they put Y plus Z grouped together and then plus this 3. Now 8x, the quantity times Y, I could change that grouping to be 8 times the quantity xy. Notice again what's in the grouping symbols has changed. But it has to be all addition or all multiplication for that associative property to work. And here's a couple more examples. And they're basically throwing them both in here. It says first use the commutative or associative laws of addition to rewrite two expressions of the equivalent, or which would be evaluated at the same value, to this expression, the quantity 7 plus x plus 3. Then simplify. Well, using the commutative law, I can change the order of this to be x plus 7. Notice what change here is in the grouping symbol. They change the order of the addition. And why did they do that? Here's a little problem solving thing, is that we tend to kind of look past, hey, I can apply these things. In fact, I could change order and change order and change order. I need to think about, what am I trying to get to? Well, I can't add what's in this grouping symbol here because I have a variable. But I do have two constants. Wouldn't it be nice if I could get those grouped together so I could actually do that addition? and that's the process we're going through, is then they change order, then they change the grouping to be put the 7 and the 3, this addition of the 7 and the 3 together in a grouping symbol, because now when that's grouped together I can use order of operations and I can add this before I deal with this adding this variable, which I can't add because I don't know what value goes in there. And I can take this expression and simplify it, or basically write an equivalent expression that has less complexity to it, really, is one way to say it. Here I only have one addition to deal with. So if I was going to evaluate this and I wanted to know when x is 5, what would that evaluate to? Well, with this simplified expression I could say, hey, that's 5 plus 10 or 15. In this original it isn't that much tougher, but I'd have to put the 5 in here for x, and I get 7 plus 5, which is 12, and then add 3 and I get 15. This is a simpler version of that expression. It gives you the same outputs for your evaluations or the value. Now the distributive property is probably one of the most used things in algebra, and this is a little more complicated because it's dealing with two operations here. We're dealing with multiplication and addition, and we illustrate a lot of things in multiplication and addition terms, which is we're going to deal with later on. We're going to deal with it. We can change any subtraction to an addition, and we can change any division into a multiplication. So when we look at things in terms of products and sums, which are the words that we're talking about here, and product, it says, here's some terminology. A product is the answer to a multiplication. The parts of the product, or the parts multiplied together, are called factors. When two numbers are added, the result is a sum. Okay? The parts of the sum are called terms. So, I mentioned one time add-ins, but terms are going to be used many times here in this course and following courses too. So they're defining these parts here. So when I have 5 times the quantity x plus 2, this is a product basically. If I put some things in here, I'm going to end up multiplying. I'm going to end up with the answer to a multiplication, even though there's some addition in here. But they'll talk about the product of those things. Well, the factors of this product, or the parts that are being multiplied together to get the answer to this multiplication, is 5 and x plus 2. Now the factor is a sum. In other words, this one factor here, this grouping, is really a sum or an addition of the terms x and 2. Okay? So throwing a lot of words at this, though they're very important words that we'll keep reusing throughout any math courses that you do. So they're saying, well, also I could have 5x, which is this multiplication of 5 times x plus 10, is considered a sum right here, because really the pieces to this thing are added here, or terms, right? So they talk about the terms of the product, the terms of this sum or addition are 5x and 10. Well, one of the terms here, this 5x, is really a product. It's a multiplication, and the factors of that are 5 and x. Okay? So nothing really new except for properties or laws, but we're setting up the terminology that's going to be important to explain the distributive law. So they're going to go through that first, and says list the terms of the expression 3s plus st plus 2s over t. Well, the terms means parts of the addition. So I look at the pieces that are being added together here, which is 3s, st, and 2s over t. Those are the terms of this expression. Now in this example 5, they have x times the quantity 3 plus y. and they want the factors. Factors are parts of the multiplication. Well, that wouldn't be 3 and y because those are parts of an addition. But x times this whole thing are factors. They're parts of the multiplication. So if they ask for factors, parts of the product, the factors of this would be x and 3 plus y. Now they're going to show us some things that work with, they're kind of setting up, hey, look at how these numbers, and I can manipulate these numbers, and I can distribute. Basically what they're doing is showing distributive property, and I get the same result, and I can do this different ways. In other words, there seems to be a common thing that happens all the time with this multiplication over an addition, is that I can rewrite this and distribute the multiplication. That's kind of where the word comes from, is I take a times the first term plus a times the second term of these addition, and we end up with a times b, plus a times c. That's the distributive law. So in example 6, they're saying multiply. In other words, perform a multiplication. Before, we couldn't do anything because of order of operations. I go, well, I need to do what's in the grouping symbol first, and I got x plus 2. I can't do that addition. I'm done. Well, this law allows me to do a multiplication over these terms that are in this grouping symbol by taking 3 times each term in there. So I end up with 3 times x, which is 3x, plus 3 times 2, which is 6. So the distributive law basically distributes the multiplication over the terms or the parts of the addition. Now it works if we have even more terms in our grouping symbol, is you would just distribute that over each term. So you take 6 times s plus 6 times 2, which is 12, plus 6 times 5w, which is 30w, right here. Okay? Now, we can, you may think that, hey, it looks like it's got to be in a certain order, and I could change the order of this because this is a multiplication. I could use the commutative property. But I think it's better to take less steps if possible. The main thing is to remember how the distributive property works, is I can distribute that multiplication of 5 times c plus 5 times 4, which is 20, even if it's over on this right side. And that key, I can see that when students work a lot of times, is that I start seeing that you're going to change the order of this to be 5 times the quantity c plus 4. I get a little concerned that you're trying to memorize a technique or you memorize some kind of pattern and not really understand what this law does, because the law can be worked either way, where if you're looking for patterns or memorizing patterns to your problems, not understanding these terminology or these laws, that is not the correct way to go about this course, for sure. These cautions come up in the book a lot, and they really are good to look at. They usually are about some common errors that happen around the distributive law. So they're illustrating things not to do, really. And it says be sure to multiply each term inside the parentheses by this. And I see this error all the time, is we have a times the quantity b plus c, and I go a times b but do not distribute to the c. Okay? Because you have to distribute over each part of the addition or terms of that sum. Now the distributive law in factoring, we use the distributive law in reverse, which I don't necessarily like that terminology, because we haven't talked about symmetry, but you can say, well, isn't it the same thing to say a times b plus a times c? I could rewrite that as a times the quantity b plus c. And the key thing here is, if you look at each term, here I have ab and this term is ac. They have a common factor. And that common factor can be basically pulled out, so we can rewrite in this form of that common factor times the terms of the addition. Okay? Okay, and that's what they're talking about here, common factors and stuff. And we've used common factors to simplify fractions, and that comes up a lot too. Okay. So example 9, they say use the distributive law to factor each of the following. So I look at the terms in this example A here. I have 3x plus 3y. Is there a common factor? Common part of each multiplication? Yeah, in this case it's 3. So they highlight this by turning it red, right? Well, because of this common factor, I can say, well, 3 could be taken times each part of that addition, and I could rewrite it as 3 times a grouping of those remaining add-ins, right, of x plus y. Now in this one, I look at this and I have 7x, 21y, and 7. Well, the common factor between all three of these, it has to be in all three for this to work, is 7. So they take 7 out, they factor out the 7 or make 7 a factor, multiply by the sum that's going to create this original expression right here. So 7x, what do I take times 7 to get 7x? Well, I need an x. And here I'd have to have a 3y to get 21y. And here's probably the part where I see a lot of errors. Well, to create this 7, I need to represent a multiplication or another term here, because really this is 7 times 1. So when I take this common factor out, or I factor it out, I have to have a number to multiply by, which would be the identity there of 1. And when we talk about this, when we have these examples like this, we can go both ways. We can multiply out or find common factors and factor. And really what they do is after I factor this, they're saying, well, what if I distribute? Would I get back to the original expression that they gave me? That's a good way to check. So good luck with this assignment, and I'll talk to you later.